So this is just my usual thing that I use to help remind myself of what we're talking about here. So welcome to Milwaukee. This is Summerfest starting, I think, next weekend in Milwaukee. As you know, this is a Badgerland user group, and most of our people are from Milwaukee, but we have invited people from across the country. So if you're outside of Wisconsin, welcome. In a couple minutes, Sigmetrix will be speaking, and up until about 12:55 Central Time. And we'll leave the last couple of minutes for questions. If we run out of topic, we won't go all the way to 12:55, but we do want to end at 12:55 in case people have 1 o'clock meetings. You should be muted. So Badgerland User Group's been around since 1994. We've been having these lunch and learns since the pandemic started, so 2.5 years ago. Don't have any specific date to restart in-person meetings. It won't be this fall. You can imagine we used to get a lot of incoming money from our vendor fees, so we haven't had that for 2.5 years, so our budget has dwindled. Speaking of that, we do have a door prize today. We used to have much more door prizes, so this is probably our only door prize for the year. So all you have to do is email me that you're interested in the door prize. And if you're a member of Badgerland User Group, these are some of our sponsors. Today is Sigmetrix, and thank you so much for speaking today. Our group is, as I said, mostly Milwaukee, but we also go Green Bay, Madison, Chicago. We do have dues. The last couple of years, we've been doing half off of dues since we don't have the in-person meetings. Not that we don't want to, but we're just waiting for it to be safe. Typically, our meetings are at Manpower Downtown, corporate office, or Blue Harbor Resort in the summer at Sheboygan Kohler. To contact us, go to badgerug.com. We also have LinkedIn and Facebook groups. Just search for Badgerland User Group. Here's my name, email, deborah.l.white@gmail. In terms of announcements, PTC LiveWorks is not happening in this year, and there's no announced plans to do it next year. However, PTC User is having a national event October 3 to 6 in Orlando. Should have about 400 people at that. So if you're interested in a larger in-person event, go to ptcuser.org, sign in. They do have a new website as of, I don't know, 2 years ago. So you'll have to log in with your email address and create a new password. For upcoming Badgerland User Group things, July 15th, we've got our usual monthly CAD Windchill Admin Roundtable at Friday at 11 a.m. If you want more information on that, if you're an admin or you work with an admin, just contact me or the LinkedIn or Facebook groups. Our next upcoming Badgerland Lunch and Learn is from EngineSoft. So one day before the admin, July 14th, again on a Thursday. And it's on multi-body dynamics, so more of an analysis thing. So tell the people that you work with that are, Creo and analysts are, doing that type of dynamic calculation stuff, that this would be something that they'd be interested in. So it's not your typical Creo user, I don't think. So we'll have to publicize that among the people that are interested in that topic. So I will mute myself. I'll try to watch the chat, but I can't guarantee. And I'll turn it over to Ross right now. Thank you so much again. I'll stop sharing.
Awesome. Thank you, Deb. Let me get my screen all pulled up here, and we'll get
I was just going to say, it looks like we've got a lot more people than had registered. We've got 30 participants, so that's great. Thank you, everybody.
Fantastic.
One more thing, sorry.
Oh, you're fine.
So usually we do this on Fridays. In the summer, we're doing it on Thursdays, just because Wisconsin people tend to, maybe go camping or fishing or go up to their cottage on Fridays or take a half a day. So this month and next month, we're doing the lunch and learns on Thursday, which you guys probably figured out. Thanks.
Great. Let me get my screen pulled up here. It was giving me a little hassle to share. There we go. You guys see my screen okay?
I can see there we go. Yep.
All right, it looks like it's blinking in and out here. So hopefully that doesn't continue.
Ross, we see the user or not the presentation mode of the PowerPoint, just so you're aware.
Thanks. Oh, give me 1 second here. It's being a little temperamental with me. All right. Let's just go ahead and share. There we go. How are we doing?
Looking good, buddy.
Excellent. All right. So thank you guys very much for having us here to speak today. My name is Ross Snyder. I'm an application engineer with Sigmetrix. What we're going to be going over today is our tool within Creo, the GD&T Advisor. And I'm going to talk a little bit about that tool's interaction with adding PMI, that product manufacturing information. We'll dive a little bit into what that means and kind of why that may be valuable to add into your process. And once we go through that, I know a couple of you, especially if you have seen any of our other presentations here with the Badgerland group, we've gone through this tool in detail, so I won't be diving too far into the weeds as far as the GD&T Advisor tool itself. Today, what we're going to be focusing on is adding that PMI information into a part, kind of as an example of walking through that. And then what I'm actually going to do is pull up another tool that we use outside of Creo as an example of what you can do downstream within your workflow with that information once you've put that information into your assemblies. So with that, go ahead and pop over to the next slide here. So what we're going to be looking at today is a caster wheel model. So this is just a standard industrial caster wheel. And as you can see here, we've got a bunch of these different annotations, different GD&T callouts, different things identified as datums. Also included in the assemblies that we use often with the tolerance analysis tool, CETOL, which is what you'll be seeing a little bit of later, is the dimensional information, the assembly constraints, things like that. That information all constitutes as PMI, that product manufacturing info. When you have that information included into your assembly, like you can see that we do in ours here, a lot of that information can be very useful downstream. You can use it for feeding other softwares, like we'll see an example of later, or you can use it for different data analyses, or at least making sure that consistently down your workflow, the information that you have included in your assembly stays consistent and doesn't get bogged down with potential human error. Case in point, a lot of the information that you typically would walk through for, let's say, a standard tolerance analysis, like you can see here, if you were using an Excel spreadsheet, you would have to go grab your drawings, take a look at things, and kind of figure out what your tolerance loop is going to look like. All of these different annotations and dimensioning information that you've got on those different prints all have to be manually collected, manually added over into your spreadsheet, or God forbid if you're running through all this on paper. And every time that you touch one of these different things, it introduces the opportunity for human error, or potentially not having the correct call or information translated to what you're using the information for. Versus adding these annotations in at the ground level in your assembly and them being a permanent fixture of your workflow walking forward. With that, what I'm going to go ahead and do is pop over to our the GD&T Advisor over in Creo that I've got open, and I will need to switch my windows here. All right. Great. So what we have here is a standard normal operating window of Creo. Now, one of the tools that we have available to us here within Creo is, and I'll close this out for a second so it looks a little bit more familiar, our GD&T Advisor, which is a tool that we created that is available directly through PTC and is a plugin directly in the Creo environment. So if we click on this, what we have is a advisory tool that is going to help walk, especially new users that aren't particularly familiar with adding geometric dimensioning and tolerancing to their parts that they're walking through. Now, this particular resource, again, just a quick add-in here within the Creo environment. We have a lot of different options as far as making sure that we have things dialed into a specific standard and that those annotations are done correctly. Because if you're putting all these in manually, especially if you're doing them on prints, or if you're even adding these annotations in manually, there's a lot of opportunity for some user error that, while it'll let you do it, doesn't necessarily adhere to the tolerancing standards that you may need to be following for your particular parts and assemblies. Case in point, if we go over here and go into our preparing our model properties here, one of the things you can see that we've got in here is the ability to change between ANSI and ISO, and my window popped away on me here. Let's try that again. There we go. We have the opportunity to change over for our ANSI and ISO areas here. There we go. Whether we want to change those, we can make those adjustments, as well as adjusting different standards, whether you're trying to follow the 14.5 for 2009 or 2018. Those can be dialed in right here within the GD&T Advisor itself, so that the annotations that it helps assist you put onto the actual part going forward, you can be confident that they're going to adhere to the standards that you're being held to inside whatever requirements that your parts have. With that, just a quick overview of kind of what and where everything is here within the tool itself, for those of you that haven't seen this before. Over here, we have our feature tree and our advisor tree. These two areas are going to be where most of the specific information, as we walk through the process of adding our different annotations, come into play. The feature tree specifically is going to start showing the different callouts that you put into place, as well as the different datum schemes that you have in there, what's being used, what's not being used, etc. Down here is the advisor tree. This is more of your information pieces and your advisory notations from the software itself. This is what's really going to let you know that you're missing things, something's not quite right, etc. Over here, obviously, we've got our main screen where we can see the part that we're working on within the Creo environment. Up here at the top, we have all of our different toolbars. This is ultimately where we're going to spend most of our time today, is just using the tolerance feature and a little bit of our properties. And I'll show you what the cool multicolored box does in a little bit as well. With that, what I'd like to do, so this part here that I have open right now may look a little bit more familiar if I rotate this, kind of like the picture that we had earlier. So this is one of the supports that was in that caster wheel assembly, where it bolted up to that top plate, and you had the wheel up in the center, and there's another one of these on the other side. So what we're going to do is we're going to add the PMI information, the actual GD&T annotations, to this part here that we're then going to later use in the CETOL environment. And I'll show you where that information, once we have it accurately placed, which is already a great thing to be able to do, can be useful downstream in your workflow as well. So with that, we can see over here, our advisor tree is letting us know that not all of our degrees of freedom in the model are being constrained properly, and some of the surfaces are also not being constrained. So those are going to be our two targets today as we go through and try to add GD&T to this part, that we really want to take care of those two items. So to start things out, we're going to need our first call out, presumably what we're going to call our datum A. So what we're going to do is we're going to hit tolerance feature. And I know that the main thing that we made up to that top plate that we've got going on is this top surface. So let's go ahead and select that, and we'll hit OK. Now, what you can see up here is that our toolbar has changed, and now we have this, this window has popped up for us to populate effectively what is going to be inside our reference frame that is for our GD&T callout. So you can see here, we can name this if we'd like to. We can pick what kind of a scheme we're going to be doing, whether it's just going to be a regular dimension or what we're targeting for everything here today is going to be our geometric tolerancing. And this is where we're going to pick the information that's going to be going into the actual frame itself. So we can see here already that it's recommending that we go with a flatness callout, which is what we're looking to do. So if you're a newer user, you're not really sure what you need to be using for things, GD&T Advisor is going to make recommendations that are logically based off of either what you have defined or the kind of surface that you've got called out. You can see there's a little asterisk right there. That's kind of the best guess the software has going on for walking through that process. So we're going to leave that as flatness here. Now, admittedly, I have a sheet in front of me that effectively is our print for this. So I know what the tolerance value needs to be. But this is where we would add our tolerance value for the actual call out, which will be 0.05. And then over here on the right, you can see that it's recommended, especially because this is one of our first features and we don't have any other datums going on, that this be a datum feature, and it is going to be our datum A. Now, we can make adjustments to that. We can turn that off if we're trying to just add a quick annotation to something. But for this particular one, the GD&T Advisor's got this spot on. We're looking good. So we'll hit the little check mark here. And then you can see that it's dropped the annotation right onto the part over here. Now, we have that first DRF that has been placed, and we're not using it for anything yet, but that'll change shortly. And we still have a couple degrees of freedom here that we need to account for. So let's go ahead and try to get our datum B in. Now, datum B is going to be over where this flat surface mates up with our bushing that pushes into here. So we'll go ahead and pick tolerance feature, and we'll select this flat surface here and hit OK. And now, again, you can see that up here at the top, it's changed, but this time our recommendations are a little bit different than they were last time. So now we have that first datum that we could potentially be referencing. It's not the only thing out here. So we've got a couple of different recommendations that the software is putting out in front of us. And perpendicularity is what we're going to be looking for. And because we're doing that, we also are going to reference that datum A for this particular callout as well, which it automatically generated. And we could potentially change that if we'd like to. But again, GD&T Advisor's got it spot on. And I'm going to go ahead and change that to a 0.1, which is what that's supposed to be here, according to our print. And datum B is what we're going to be leaving that as. We can go ahead and check that box and hit OK. So now we've got those two callouts, and that's looking good. Still missing a couple things here for controlling this for all of our different degrees of freedom. And it looks like we took care of that, not using our DRF for just A, but now AB is not being used. Well, we'll be taking care of that when we add in our datum C, which we'll do on this back surface here. So we'll have that flat, this flat, and this flat here to control our different degrees of freedom. Now, looking up again, this is recommending us use the perpendicularity, which is fine. But as we open this up, there are some different other options that you could use. Something that's cool about this as well is that if you hover over some different items, it will also give you explanations for why it probably isn't the best choice to be using for where you're at right now. And again, we got our little asterisk, so we're going to leave that there. And this one is another 0.1. That's referencing our AB, which is what we needed over here, and is going to be our datum C. So we're looking good there. Now, something else to keep in mind is if you were looking to add further refinement to any of these, that's something that you can do over here. And you can add additional layers to your callouts here, but we're going to go ahead and put that back to just the single callouts because I would like this to match our assembly that we're working towards later, so that we can see the progress between doing this and using it. So we've got our A, B, and C callouts here, and I will say that we are going to add another callout here because this is a fairly critical feature. I'm going to go ahead and tolerance the actual hole that our bushing goes through and our axle goes through, and hit OK. Now, as we go through, again, walking through the process and the recommendations, it's got our position tolerance in place, which is what we're looking to do. And that particular value is going to be another 0.1. We only need this for referencing A is what we're looking for the, I'm sorry, nope, this is supposed to be A, B, and C, and this is exactly what the recommendations were right out the gate. And something else we could also consider doing is adding this as an additional datum if we need to reference this ahead. Now, you know, let's say you've got a new user working through this and everything is going okay. And it's like, okay, well, I'm adding another call out. This has to be another datum. So let's turn that on as a datum feature for right now. And we're going to leave this at RFS and hit OK. Now, while not technically wrong, especially because we're still mid-process, one of the things that is probably not what we're looking to do here is we've called this out as datum D, but we're not. This was the last call out that we really needed to do for this particular part, in addition to the regular dimensions that are already in place in the actual assembly. We're not going to be using this for anything. And over here in the advisor tree, you can see that it's letting us know that it's not being referenced by anything. So let's go ahead and we're going to edit that. And we're going to turn that off as datum D. We really don't need to do that. But it's nice to know that that alert to the fact that you're not going to be using anything can be really beneficial for especially some of your newer users. Now, we've taken care of all the different callouts that we really need for moving forward with this particular part here, but the advisor tree is not quite happy. Well, this is where some of our other tools are going to come into place. So there are some different surfaces that are not constrained within this assembly, and we'd like to at least give some sort of a basic tolerance to those items so they don't get too out of control. Up here at the top, we have show hide constraint state tool. Now, if you click on this, this is one of our visualization tools, and this is going to highlight all the different items that you have specifically identified with a tolerance, and so that they are fully constrained, partially constrained, or in the case of most of the other surfaces here, unconstrained. So what we'd like to do is control all of the rest of those with a surface callout. Now, I'm going to go ahead and turn that off. All we have to do that is go over into our properties and notes, and we can actually add a general profile tolerance directly to the area. And we'll just leave that as a nice soft 0.5 and hit OK. Now, as we add that in here, you'll see that the note drops in for what we needed to do. And if we click on that button again, all those blue surfaces are the ones that are controlled by this particular note here. And all the green ones are the ones that we specifically defined, particularly with the datums, but with everything else that we got going on. So overall, that is what the quick sample of the process of walking through GD&T Advisor looks like with your tolerancing information. Now, something to keep in mind is that this is not just to figure things out. This is actually annotating the part itself and authoring these things instead of using the onboarding annotation tools, because sometimes they can get a little hairy or let you do some things that aren't technically in accordance with some of the standards that you need to be following. With that, I'm going to go ahead and jump us over to the next tool, but let's go ahead and talk about that for just a second here. So what we're going to be doing in CETOL here, which CETOL is a tool that we over at Sigmetrix put together to do tolerance analysis in the three-dimensional space. It pairs up with your assembly and allows you to not only just crunch the numbers for your actual tolerance analysis, but there's a lot more functionality and interactivity with the actual tool itself. So what we're going to be doing today is we're going to be taking the model that we did all of those annotations for this part right here. Those annotations have already been done to save you guys watching me walk through every single one of these individual parts, doing the same. And that information is going to import and come through our tool CETOL, but this could be a number of different tools that interact with that information. You know, having that available within your assembly can be very useful downstream. This is just one example of being able to use that info. So what we're going to be doing within the CETOL tool today is just a really quick tolerance stack up of this exact stack. So what we're going to be doing is taking a look at the vertical alignment of the center axis of these bushings, effectively the center line where the axle is going to be running, the vertical coaxiality of it. So what we have over here is, just the usual prints. This is what I was working off of before, in addition to some other notes. And down here is where you would normally stack that tolerance information. The process that we're going to walk through is we're going to first identify the different critical surfaces that we have within our assembly in CETOL. Then what we're going to be doing is, once we've figured that out, our step 2 is going to be adding the dimensions and constraints and the different dimensional definitions that we have for our assembly, so that we know that that tolerancing information is accurate. Now, this is really where you'll see that PMI come to play and be useful, because typically our tool is capable of being used whether or not you're manually adding the different information from your GD&T callouts or standard dimensions. But something else that we can also do here within our tool is import a lot of that PMI. And this is kind of the example that I'm building over here, is that, a lot of that information you are going to be putting on your drawings anyway. If you take the time and you put it in your assembly, a lot of tools, a lot of digital tools and resources that talk with your dimension or your design information can take a lot of that directly from the actual CAD files and work with it, instead of you having to manually input everything. And that's going to be the case here, as we import a lot of not only just the GD&T calls that we put in here, but the basic dimensions that we have in place for the actual parts that are in our assembly here, as well as assembly constraints as well. And then from there, I'll show you guys real quick what the results of that are, but we won't dive into too much details. I'm not trying to talk you guys over too many different software items today. So with that, I'm going to jump back over into Creo, and we're going to bring up the CETOL tool. Now, over here, what we've got going on is this window over here is CETOL. It's effectively a side-by-side bolt-on for the tolerance analysis software. And over here, just the assembly of the part that we were working with earlier. And again, I left these on for a second so you can see we have all those different annotations like we were working with before. But I'm going to turn them off because they get a little much to look through and everything while we're walking through this. Over here on the right-hand side, just to give you kind of the 10-cent tour of CETOL here, we've got our measurement tree and our model tree. We refer to tolerance stacks in CETOL as a measurement. So you'll hear me throw that word around a little bit today. Over here on the right is our properties window. As I pick and click my way through different things, you'll see this window change with the different details of the things that we have highlighted. Down here, we have our advisor window. This is really similar to what we saw in the GD&T Advisor tool, in that advisor tree that we are getting those notifications. Very similar over here, except for this is going to be our advisor through the tolerance stack up process of what we're walking through today. And those 3 steps that we walked through really quickly in the PowerPoint we were just looking at are mirrored here in our toolbars as well. So we've got step 1 where we're going to be defining the actual stack up that we're going to be doing with a new measurement. Step 2 is where you would be adding that dimensional information. And step 3 is where we take a look at our results. So with that, I'm going to go ahead and get started. And first and foremost, let's go ahead and hide these couple items here because they tend to get in the way. There we go. So what we're going to do is we're going to add a measurement here and pick our way over in the Creo environment through the, we have to relink our guys here first. There we go. And what we have to do is go through and pick the different items that pertain to the tolerance analysis that we're running. So we know between those 2 bushings is what we were looking at before, but that visualization that we get up here as we start defining things doesn't look quite like what we were trying to target here for this particular analysis. So all we have to do is make some adjustments to the directions that are referenced for that vertical component. So now we can see those arrows are up and down, as well as let's go ahead and change this to axis here and lock that back up. And then just so you guys know, the results that we were targeting for the spreadsheet that we were just looking at were plus or minus 0.75. In case you missed that, just not pulling the numbers over here out of thin air, but we'll set our requirements as well, just so we have those moving forward. And now you can see over here in the window with the actual part that we have that center axis, and I'll rotate this a little bit because it's probably hard to see on your screen with that white. We've got that center axis that we're trying to measure off of in a vertical direction, referencing that top surface here. So looking good, we'll hit OK. Now, over here on the right, you can see that not only has our advisor window changed over here from, hey, you need to get the ball rolling, to, hey, you've got some stuff that's under constrained. We can click on those and see that those bushings that we're trying to measure between that yellow set of arrows is letting us know all the different degrees of freedom that we're trying to take into consideration that are not being constrained right now. Over here in your modeling tree, you can see the information start to populate for what CETOL sees as part of your tolerance stackup. Now, we also have a cool visualization tool in here, like we do in GD&T Advisor, except for this one is going to let us know what CETOL actually sees as included in the overall stackup. And after I click that, you can see that, wow, a whole lot of different parts just disappeared from here. What gives? Well, right now, all that CETOL has to go off of for all of the different items that we've got in play here is the 2 bushings and the referenced surface that we used to define our problem first. We need to add in all the rest of those components, because as we start adding all those different items in, that information is going to come over and help us constrain those under constrained items so that we don't have to manually do it ourselves. So let's go ahead and we're going to add component, and we're going to walk through here and walk down our list. And we can see here that, make sure I hit both of the hex flanges here. And I'm going to hit show locations again, because you can see that down in the advisor, every time we select something, it updates to keep us up with the latest of the information that we're working with in the session. We can see that we still have that one bushing that's under constraint, but the other one looks like it went away. So if I hit show locations, as we added those different items that control where that bushing's at, our support that we were working with earlier and the 2 screws that go into here, you can see that it took care of that. Now, part of the reason it took care of that, and we'll dive into this a little bit more, is as you can see, all these different light items here are more than just the part names. These different items, as we start adding these in here, are all of the different bits of information that we are able to pull out of our assembly into CETOL. And this is what I'm talking about with that PMI. So now that we've got no more errors, everything's been controlled by those different items that we've brought in here, you can see, man, there sure are a lot of line items over here in our modeling tree. Now, if we start expanding some of these items, you can see that our datum information, the GD&T callouts that we've added in here, our dimensional information for features of size, that information has all come directly from our assembly. Now, this is really where the time save comes in, because while CETOL is able to take any degree of you having those different items here, by having that fully defined and fully constrained, this is typically where we would jump to step 2, because we don't have any more errors in the advisor window. It's just letting us know that we can make some adjustments to the way that our fasteners interact with things, for instance, floating them, but we don't need to dive into a lot of that here today. This is where we would jump over into tab 2 and start working with our dimensions. But because our part has been fully dimensioned and we have all those GD&T annotations inside the different parts within our assembly, we don't have any outstanding requirements for the problem that we've set forth to add in here. There is no manual dimensioning that needs to be done right now. So that saves us a tremendous amount of time for basically doing the same work we would have had to do on paper with our prints anyway. We just moved up the timeline a little bit and did it with our initial design phase. And now all that information is available to us over here, including our assembly constraints, the GD&T callouts, et cetera, for all those different components, or at least the components that it's available for if we necessarily didn't happen to have all those. Let's say your vendor sent you that top plate or something and didn't really send any of that. The rest of the information would still come in. You just would need to manually add that. So if we were to go through and do that, we could isolate one of these components. We'll take the one that we were working on earlier as an example and go through and add those different dimensions just by adding a dimension and walking through the process of doing that. But as you can see here, there's our datum A, that top surface that we were working with. Datum B, that flat that we were working off of there, is our datum C, that back surface, as well as we've got that as datum D in here just to showcase that example. But remember, we weren't using anything. And because we used that GD&T Advisor, we knew that best practice was to pull that off as the actual datum. But that information is still the information that we populated in there earlier, as well as other GD&T callouts that we potentially could add in as well. So all that information has been ported over here, saved us from having to add this in manually. There's a lot of really intelligent tools out there these days that tie into that information, and that can be really beneficial to your overall workflow and saving time and making sure that you don't have to manually add in each one of those things and risk fudging a number or something, or accidentally transposing two different dimensions and your results being all out of whack. Something else that's also really cool here, and we'll skip over step 2 because we did it ahead of time and we're ahead of the curve here, and jump over into our analyze window, and we'll hit solve and take a look at our results. Now, what's cool here is that, so CETOL gives us the results for our worst case and our statistical results for our tolerance analysis, our distribution information, our quality metrics. We can adjust the requirements if what we put in there, or if we didn't put anything in there before, wasn't quite right. Something else we can also do is add particular CPK targets. If you've got a sigma value that you're looking for, things like that, you can drop those in as well. CETOL also allows us to take a look at some of the sensitivities and contributions here. But one of the things that I like to use within the tool is another one of the visualization tools. So I'll show you guys this real quick because it's kind of neat. If we take a look at the visualized variation, this is going to just run us through an animation real quick of the upper and lower limits of our overall stack up and kind of positionally where our worst case is looking. And as we can see here, hold on, let's start that animation up again. We've got a little wiggle in our part, and our part was successful when we looked at that particular study in the one-dimensional analysis that was in Excel, that was in our PowerPoint presentation we looked at earlier. But it looks like we're kind of on the out of bounds area here for running it through CETOL. What gives? Well, having looked at that rotation, it looks like there's a rotational element that we missed or we're not seeing within the other study, because that makes sense. We're using a 3-dimensional tool that has all of our data, not a 1-dimensional tool like Excel to walk through that process. So to further kind of bring that in and take a look at maybe why that is, our sensitivities tab is going to give you a hierarchy of highest to lowest impacts of your study as far as your measurement and dimensional information goes within the part. Now, this is a fairly linear study. These are your linear sensitivities. Moving 1 millimeter impacting your results 1 millimeter, not really jarring, nothing really out of the ordinary here. But if we look at our angular sensitivities, you can see that that's definitely not 1-to-1. And as we highlight these different items, they highlight over here in our Creo and showcase that exact rotation that we were looking at before in those 2 different areas. Okay. So we're on the right track. That's looking like the right area that we need to be focusing on. And as we have those selected, it's also highlighting those different items here in our measurement tree. Our contributions tab will help us dial this in a little bit further. And something else to consider is this is going to give us the main contributors to our overall results from a tolerancing standpoint. The different degrees of variation that we could potentially have for different things within the tolerance range that we've got. And as we can see here, the largest contributors that we've got are those 2 surfaces here that have that surface call out that we have put in place, that 0.5. So again, our PMI is coming to bat here and letting us know that what we've got going on. But something cool that we have over here in CETOL is we can directly interface with that data that we brought in from our actual assembly and make quick what if studies. And let's tighten that tolerance up a little bit and see what happens. So if we bring that in, we've adjusted that surface call out from a 0.5 to a 0.2. Now that may seem drastic, and it looks pretty drastic, especially considering where our statistical results are, but we can play around and we can back that off to maybe something that makes a little bit more sense, but isn't quite so within the confines of what we're looking at. So there's a lot of different ways to use that information that not only we've added with GD&T Advisor, but PMI in general. When you add those annotations inside your assembly, that information is part of the workflow now. A lot of different tools, a lot of different resources, whether ours or others, like to talk to that information, tie into that data, and can be really beneficial to problem solving things without having to completely reiterate problems over and over again for a bunch of studies you don't quite have enough information to justify. Again, like you saw before, it also can help save on some of the manual dimensioning time, or in our case, a whole lot of time for your tolerance studies and tolerance stack-ups as well. From there, we were happy to take a look at our results. We were able to run through all these different informations. Something else that's also really cool that our tool can do with the PMI data as well is typically we leave our CETOL tool defaulted to a non-authoring tool. So the information is flowing one way from your assembly over to CETOL. If you wanted to really run a pretty interesting what if study, and you were in the middle of updating different designs and people were playing with these different values, you didn't want to have to worry about relinking this and then that value being different and not being what you were studying. You can actually unlink these different annotations that were imported, so you can completely change them and what their DRFs are and what kind of a call out that you're looking to do right here within the tool. Something else you can also do is, instead of making the CAD properties driving those changes, you can also make the CETOL properties drive those changes, which is why you have to take it off default to do that. We don't want anyone messing around with the CAD data that they're not supposed to be on accident. So we kind of left that as you need to select this, but this way you can push that information back over here instead as your studies become successful and you work through the different options that you have for problem solving within CETOL in order to drive decisions and changes within your overall assembly. And once you're happy with your results, then you can lock those in, make your prints. Now, because we have all that annotation information, we can drag that information directly into our 2D prints from here instead of having to manually add all those different items. And again, risk human error potentially being a factor for translating from whatever we were doing for our tolerance analysis back over to our prints, back over to our actual CAD data if we have to make any CAD data changes, things like that. So with that kind of concludes the overall look at what we're doing here with the from start to finish of adding those annotations and then being able to consume that annotation information and make it something that's not only beneficial to you from a resource for tolerance analysis, but also make your life a little easier and a little less time consuming to walk through those processes as well. With that, I guess I will open up the floor to any comments, questions, concerns, and hopefully we'll get you guys a little bit of your lunchtime back here at the end as well. Did anybody have any kind of questions on what we saw today or anything?
I just wanted to add that if people would feel more free about asking questions, knowing that you're not recorded, Sigmetrix has offered to clean up this recording. So the first couple minutes of dead space plus the last few minutes of questions and answers, we can edit that out if that would make you more comfortable about otherwise we can end early. Just let me know.
I just have a very general question about where I could access to take a look at this recording again, please.
Sure. We will post it on our website, badgerug.com. It might take a couple of days. We've got a volunteer website guy. It takes about, I don't know, 30, 60 minutes for it to come back to me, the Zoom link. And I will post that on our Facebook and LinkedIn group. And like I said, Sigmetrix will clean it up. That'll probably take a couple hours. So then I will repost that cleaned up version onto the website or onto LinkedIn and Facebook groups.
Thank you.
Sure.
And Mark, I saw your chat. You had a question about how this compares to CETOL, the tolerance analysis tool that's within Creo. Also ours. And the main difference between the two of them is CETOL is very much a one-dimensional first step into using tolerance analysis with your 3D models and everything. It's a really good tool. we just, the difference between the two of them is primarily that is more of a one-dimensional analysis, getting you out of spreadsheets, but still covering multiple of the same functions, but you still get to, you can still do a lot of the what if studies and taking a look at a bunch of different items and how they compare at once, versus CETOL is a little bit more of an in-depth tool, a lot more three-dimensional look at the entire part. You'll actually notice that there is there's a little bit of an indicator inside there that will let you know that things are potentially in 3D space. So that's basically the biggest difference between the two of them is one-dimensional for EZTA and three-dimensional for CETOL. CETOL's got a lot of other bells and whistles, temperature impacts to your overall studies. The reporting feature is a lot more in-depth. You can dump out reports on both of them. The EZTA reporting is very quick and easy, but doesn't show a whole lot of granular information, whereas you can get pretty granular within the reporting feature of the CETOL tool itself. And actually, one of the that brings up a good point, and maybe the next time we come talk, I'll walk you guys through the EZTA tool as well, and we can dive into some depth on that. But if you have further questions about the difference between the two of them, just so that we don't get stuck talking too much about the tool that's not in Creo here, feel free to reach out, and I'd be happy to walk you through it.
One thing I'll speak up. This is Kyle Hightower with Sigmetrix. I see a lot of familiar names and faces. So for those, though, that are new to any of the tools from an access piece, a lot of times people, especially now with PTC rolling out their subscription-based access, with the tier 3 subscription, you will have access to GD&T Advisor as well as EZTA or CETOL. Those two fully immersed and embedded tools from Sigmetrix with PTC. For CETOL, there are a lot of you, I do know, that are current CETOL customers, but that access is a little bit different and is sold directly from Sigmetrix. But training for any of these tools is supported by Sigmetrix. We do have a couple different methods, whether it's self-paced online training or in-person instructor-led or virtual.
Great, thank you, Kyle.
And depending on current future compliancy, but one of the pieces as well for all of the three tools, I know in Creo 9, the version of EZTA in the future, we are looking to hopefully have that be a more connected piece where you'll be able to start in GD&T Advisor, put those annotation in, import into EZTA, the 1D tool, and then take that piece and bring it into CETOL that already started one-dimensional tolerance stack. So that'll be something to look forward to, I would say, in the 2023 timeframe that we've been looking for Creo 9 users. Whether it goes backwards, I think that's a question mark still.
That's a question on the development team's desk right now.
Yeah.
Did anybody else have any questions on what we saw today?
Perfect.
Great. Well, then I give you guys back 15 minutes of your lunch hour. I really appreciate you guys spending some time with us here today to walk through some of this. And as I said before, if anybody has any questions as you kind of think back and maybe didn't get a chance to ask them here, please feel free to reach out to any of us. They'll get back to me, myself, Kyle, or one of our other teammates and find the right home so we can get you the right answer. But we'd be happy to talk to you about it in further detail if you have anything that didn't get covered here today.
Awesome.
Thanks a lot, Ross and Kyle. We'll end this and appreciate everybody's time. Thanks.
Absolutely. Thank you.
Thank you, everyone.
Thank you.